Hello and welcome to this new session about animation in Compose. In this session, we are going to have Muhammad Said, and he is going to share us what's new in Compose and animation and how we can create some beautiful animations using Compose. Just bear with me, he is having some technicality and he is going to join us soon.
Alright.
Alaikum salam. And here Muhammad Said join us to start this beautiful session about animation in Compose.
Thank you,
How
Sheikh.
is it?
Right. So, should I start sharing my screen right now?
Please do. And give your attendees a small introduction about yourself.
Yeah, for sure. First of all, sorry for being late. Uh, I guess for today's session, we are going to talk about animation in Jetpack Compose, the English version. We did this before, but in Arabic. Now we are going to do this in English, I guess. Yeah, it's about showcase of animation in Compose in general, and with some examples as well. Right, a little bit about myself is my name is Mohammed Said and I'm Senior Android Engineer at Yassir, Extendilla. Have like 5+ years of experience in native Android apps development and also was a charity member of the Risala, very well known in Egypt. Yeah, about technologies and tools that I love and I really like to use is the first of all Kotlin, KMB, Kotlin multi-platform, Compose Swift and Flutter as well. Uh, yeah, so an overview about today's session. Animation in general is very essential if you'd like to introduce an app that it's very appealing to the user and also increase your user engagement to the app. It makes it very smooth and also understandable from the user perspective. Uh, yeah, so imagine you work on an app. You do a lot of good architecture at the back end. I mean, in the code itself, very well structured and all of that, but it's not very well in terms of user experience, not very well. So I think animation is a key tool here that we can use to enhance our user engagement and usability for the app. All right, so quick guide on today's points that we are going to talk about. I think we have many built-in animation tool mechanism that we can use. Out of the box, we can use it. Will helps us in the animation, animating our composable functions very well and very easily as well. So I think a lot of built-in animation functions that we can use. We will talk about today about this set of tools, I mean functions. Animated visibility, animate background color, animate the size of a composable, animate position as of composable, and also animate text color. We'll go one by one, through one by one. So let's start by animated visibility. I think by looking at the right of the screen that we will see, we'll be able to see like a box that it's going to be invisible and visible on a certain user action. Like for example here, user click. I think we can apply this kind of animation very easily by using animated visibility here. Let's just put get the marker. So using animated visibility widget and wrapping whatever part of the code that we need to composable function that we need to animate, wrap it with this animated visibility, and we can have the control outside of the function by just like passing a boolean variable. This should be remembered while a recomposition happens. It's not like going to be recreated again. It should be remembered its value. So we can do this by using delegation, and I think the way that we are doing it is using mutable state of, and we set like a default value. It's very easy. We can control this value later when we, for example, click on a book and that box, for example, the green one. So whenever we click on it, we change that variable from like for example true to be false, and this will re-trigger the recomposition of this view. And it will like getting the new value, which in this case it will be false. By doing this, we'll be able to animate the make it invisible, but in animation out of the box. We can control, I believe, the specifications for this function by changing like the animation and how it actually goes, like the enter animation and exit animation, all of that. We can add another default, another parameter that we can control this kind of animation. So far, so good. Shadi, let me know. I guess, yeah, if there is any questions up till now.
No, everything is going fine, and the questions we can save it to the end.
All right. Yeah, for sure. Moving forward, I believe we have another tool we can use as well. It's called animate color as a state. The study is about animating background color. We can do this easily by using like this function. It's in Compose itself. We didn't create it. We can use it out of the box by creating as well a variable and use animate color as a state. We have multiple variants for this function. We can use like animate float as a state. We can use animate, a position, I believe, or size as a state. So we can have different variants for this specific function. But for this case, we are animating the color. It's the same idea. If you go back to the previous slide, we have like this Boolean variables that we can change on a certain action. We have similar one here. So whenever we have like this value change it will be like select a certain color, and this function what it's going to do is animating from one color to another and vice versa. So I believe that's what's actually going here. Based on this value, if it's true, we'll animate to the green color. If it's false, it will animate from green to blue color. So it's going back and forth between these two values whenever we change that Boolean here. I guess we can then set this result animation as a state, because when as the animation goes, it's returning here in the animated color, and by setting this animated color as a background, you see that it's actually animating from one certain color to another. So it's not like a static switching between both colors, but it's animating the values between this color and this color. I think it's more understandable if we are animating integer as a state or a float as a state, the float value changes. Let's say that we have 0 and 1 as a start and end. I guess it's going to be 0.1 and then 0.2 until it reaches to the one value. So animating between two different values. Here we are animating color as a state. Yeah, moving forward, I believe now it's more understandable for you that we again we are using, like, for example, a boolean that, but for now we are going to control the size of the composable. Controlling the size, what I mean is, like in this example, we are controlling the height or changing and animating the height from a certain value to another one, from 200 to 400 dB, and also vice versa based on a certain boolean if it changed on a certain action. As we can see here, we are changing this on a certain user click, and we are like make it like if it's true we are making false, and if it's false we are making true, and this will re-trigger this box composable with the new values based on this expanded value changing. So it will trigger between false and true, and then if it's true, as it comes here in the recomposition, and say if it's expanded equal true, then we will animate to the size of 400. If it's false, we will animate to the size of 200. So and it goes back and forth again and again. Yeah, I guess the idea overall it's now like more clear. Another example, but for a position of an composable. Whenever we have like a composable that we need to animate its position, we can easily do this by using the offset. Offset is the position of the composable in the screen, and we can use in this animate integer offset as a state. As I said, we have variants of this function, so we now have the integer offset, and we can animate integer offset as a state. I guess how it works is the same idea. Suppose that we have a default value which is integer offset.0. This indicates that on the screen it will be on the top left side of the screen, so in this position here, as it's the 0 offset. I think this would be the default one. Then if we change the variable again by triggering a certain action, as we can see here on a user click, this will leads to go to this place and recompose whatever composable here based on this value changing. And if this change, it will be affecting like, for example, this value, because the offset here is also depends on the moved variable, and if it's changed, it will be like go back and forth between the integer offset of a certain values to an integer offset the 0, which is 0 and 0 like x and y, and then it will if it's changed, it will go to another x and y as we put it here at 200 dB. This is the exact positions that it's going to move to, which is 100 pixel and 100 pixel in the screen. Yeah, so that's, but in an animation again, so it's not going to suddenly appear in a certain position and disappear in the other, but it's going to animate from this position to the other one. Right, so moving forward, I believe the next one is a little bit different. It's animating the color again, but it's actually animate this in an infinite way that we are using, like, remember, infinite transition. And by using this infinite transition, we can infinitely animating whatever, like for example, here we are animating color, and we set an initial value, which let's say that's a green color, and then target value could be the blue one, and we can animate this back and forth based on a certain animation specs between a starting initial value to a target value. This will goes forever. It's not going to stop. It's infinite transition, and we can just set the animated color here as the, for example, the text color. Very easily, very smooth as well. Right, moving forward to another like animation topic, but it's a little bit different. We have the shared element transition in Jetpack Compose available starting Compose 1.7. I think it's in beta right now. It's not stable, but at least we can try it. Yeah, as you can see here, actually these are two different Compose screens. One that let's say that we have a list of items, and then we have the details for this item. On clicking on certain item, it goes to the details screen. Yeah, how we can achieve that very easily? As we can see here, we just define the we have the screens here. Let's say that we have the container for it, which is animated content. But typically we can have nav host, and in this nav host will contain like different Compose screens. But for simplicity here, we can, as we can see here, we have different two screens, and based on a certain action, we are changing the visibility for certain one over the other one. So let's say that we have a main content and the details content. What we are going to do here is that we are adding a shared transition layout very easily when we just put the dependency of the transition updating the Compose version to this version. We can easily import this shared transition layout, wrap the whole container with it, and then inside it, we just refer to this context of this composable. And then I believe what we are doing here is animated visibility scope as well. It's referring to the place where we have the container one. It's referring to the container view. Yeah, we will be able to then inside these screens itself, we will use these two variables. So let's say for example, in the main content, we have the transition scope and the animated visibility scope. What we are going to do is that, as you can see here, we have a new modifier. It's called shared element. We set a certain, like for example, what we are animating here is the image, text, and the description. So what we can do is that let's say that we are going to annotate or mark the image by a certain key inside the shared element. This key will be used in the other screen as well, as you can see here. This will let the animation and element transition knows that we are going to animate from this element, which is an image, to this element as well, but in the which is an image as well, but in the details content, by defining the key inside here and here. So by marking this key here, certain key, and calling again the same key, it will be known that we are going to transit from one element to another element in the screen, as we are setting tag for it. And also we are passing the animated visibility scope here and here. It's the same scope that we are animating the visibility in it. All of this happens inside shared transition scope, as I said. So this should be in the context of the shared transition scope. Yeah, that's it. I believe very easily we can achieve that. animation here by doing just these settings, these configurations. So yeah, moving forward, I believe testing animation is easy as well. It's just by running this code, you can test the animation by initialize it and then let the animation proceed by using this advanced time bind. This makes the behavior expected. Yeah, so I guess moving forward, we have something very interesting in the Compose. It was available in the XML as well. It's called MotionLayout, but it's now a little bit easy in a comparison with the XML one. As you can see here, with the motion layout, we can really do a complex animation based on a certain scene. Certain scenes, as we have like a start scene and end scene. As you can see here, let's suppose that we have the light version of the scene is the starting one, and the dark one or the night one, it's the ending one. And between, we are controlling some properties for the objects that we have. Basically, it's or typically these objects are like normal composable component. Let's say that we have an image here, and also maybe we have a color as a background. As you can see, it's going from like light blue to dark blue. We have an image as well. We are translating its exposition. We have this light. We are animating the visibility for it. Yeah, I think the position as well here. If you can see that we are animating the alpha value for this cloud. And the color for this circle, which is from the sun to the moon. We are changing the color, animating color as well. But for now, it's in the motion layout. It's not in using the properties that we just described earlier. How we can do this? What we are going to do is that we are defining a motion scene. I'm going to go through this code in a little bit, but it's typically a file in I think, I forget the format of it or the extension, but it's a file that we can store in the raw folder, and we just give this motion scene file into the motion scene object here inside the motion layout. So we define a composable. It's called motion layout. We define the motion scene, and we set the progress for this scene. As you can see here, I'm having like a progress bar, and by sliding this over this progress bar, I can define the progress, and based on this progress, I'm passing it as a value to the motion layout, and it's internally animates through the scene itself that we have here, because we inside this full file, we have like the start scene and the end scene and what happens in between. Yeah, so I guess that's the file that I'm referring to, which is the motion scene.xml, I believe. It contains of, let's say that we are going to take one simple example. I will share this resources and the full project at the end of this slides. But I'm taking just an example for presentation purpose here, that we have the sun and moon, which is this circle here. It has a start and it has an end, and we can control the transition between the start and the end. What I'm doing here is that how we can read this at the start of the animation, for this element. And at the end, these specifications or properties change it to different. So for example, here at starting, we have the width and height by 16, but at the end, it's going to be 45, which we can see here that this size is actually bigger than the end one. So the start one is bigger than the end one. What else we have here? So we have the position for this object, which is what is the start of this object? The start is related to the parent start. So how we can read it? We can read it like this. So it's related to the parent start, but it's away from the start by 20 dB or I think pixel. So it's away from the start by 20, and also it's from the top of the parent. So it's the top of this object will be related to parent top. So it's parent top, but it's away from it by the same value. Yeah, so I guess we will go.
I am afraid we are running out of time of this session. So if we can finish the rest of the slides in Hilt.
Yeah, sure, no problem. So I guess it's very explanatory as we have a start and end of the scene, and then we are having some specs that we can control the scene. The code will be available, so for the sake of the time, we can just keep it for now. Yeah, I guess last but not least is the this animation that we can have with the constraint layout in Compose as well. It's very easy to do this animation in Compose. If we would like to do this in XML, it will be very, I think, hard in comparison with Compose. Yeah, I guess if we have time shared, we can go through this code. If we are not, I believe the resources will be available as well.
Okay, perfect. Let's leave the resources, and I believe they can revisit these resources, and if they do have any questions, they can jump and ask you on LinkedIn.
Yeah, for sure, anytime. Yeah, so I guess that's it for me. If you guys have any questions.
Till now, I didn't receive any questions. So I believe that's it. And as I mentioned, if they do have any questions, they can jump and ask you on LinkedIn for any questions that they came up with. Thank you for this animation session in Compose, and waiting to see
Thank
you.
you so much.
Thank you, Mohammed.
Thank you so much. Yeah, you too. See you.
Thank you all, and waiting for you to join us on the last meeting for today. Okay, so let's go.